struggles and all aspects of life. Source of wisdom to us so that we be able to differentiate between what's wrong and right and able to understand. Bless our teachers. May they give best to us and may we get best from them. We pray this through Christ our Lord. Amen.
Amen. Thank you very much, Queen. And thank you very much, everyone, for coming on. This is our first meeting this break. And I welcome each one of you to the meeting. Now, because we haven't had any other meeting before, I may not have considered your interests, and I may not know exactly what the interests are. We shall spare a few minutes. I don't know. I think it is better to spare them at the end so that we discuss what exactly we may need. But for me, I sat down and thought that we could discuss vectors. This is pure mathematics. We could discuss vectors, and this is a topic that everyone can discuss at any one time. Then if we are to discuss any other thing, I could get it from you. Hope that is okay. And if that is, may I request John and the rest to mute so that we can go on then with our meeting. John and those who have not muted, can you mute, please? Then we could go on. Okay. What do we have to discuss now when it comes to vectors? And may I request those who have not named themselves to name. Please name yourself so that we can talk better. Vectors is something that is not new. We have done vectors as small guys at all levels. And it is the same thing that we are going now to allow to grow. So we are going to meet in the same thing that we have made, that you already know, only that now we shall get a chance and then take it slightly higher. Otherwise, it's not any different. It's what we know already. What do you know about vectors? Or if I may say, what is a vector to you? What is a vector? I want to get feedback. What is vector? What is vector? Anyone to share with us what a vector is to them? Yes, you are unmuted. Can you please mute or share with us? Jacobs is in the chat is saying a vector is a quantity with both magnitude and direction. Thank you. I also see, who is this one? It's saying it has magnitude. Shadia has magnitude and direction. It is in the chat. Can I have someone talk to us? Tell us what they think of vector. Okay, those ideas are okay that we have here for vectors. Has magnitude and direction. Actually, those are the main things. If I'm talking about vectors, I'm talking about a quantity for which it is important to state the magnitude, its magnitude and its direction. That's what a vector is. Okay, hopefully I'm getting feedback, unfortunately. But anyway, when if the quantity is not vector, what is it? If a quantity is not a vector quantity, what a quantity is it?
Yes, sir.
If a quantity is not a vector quantity, what a quantity is it? Yeah, Innocent, it says scalar. Mixer says scalar. Someone is saying my network. Are you sure it is my network? Let me see if I can improve in my network. Okay, you keep feeding me back if I am improving, but I didn't think I had issues with my network as such. But keep checking, then you feed me in. Okay. Can I hear from you? We have agreed that a quantity, if it is not a vector quantity, then it is a scalar quantity. I want to mention this, that if I was moving from one point A, suppose somewhere here is a point A, and I'm moving from that point somewhere here. This is my point A. And I'm moving from this point, and I move from here to point B, somewhere there. Suppose here is point B. And suppose this is 10 kilometers from A to B. And then from B, I move on to C. Suppose I move from B and I go to C somewhere there. And the C is somewhere where I have C. It is 20 kilometers from B. Truth is that from A to B is 10 kilometers and from B to C is 20 kilometers. So a person moving to C through B will have moved 30 kilometers. Hope that is better. I see Dorothy here with a challenge. Sound is available, Dorothy, so you can't hear anyway. Let me send a message to Dorothy here. It's not aware that we can. Give me a minute, please. So Dorothy, please get out and get back in with a mic. Okay, hopefully Dorothy will get to read the message. Sorry for that. Then we could continue. To improve our network, may I request that those who have their videos on could remove them for a short while. You'll get back, you'll put it back later on. Because sometimes it affects the network. So if you have your video on, you can mute it for a while. You put it on again later on. Okay, I was saying that if I move the 10 kilometers and move it to a point B from A, and then from B to C, I move another 20 kilometers. The truth is that I'll have moved the 30 kilometers from A to C. But the direct distance from A to C is not going to be 30. The direct distance from A to C is not going to be 30. So if I move the here from A to C, my direct distance here will not be 30. So this here is not 30. AC is not exactly 30. But we know very well, so I can move from A to C directly. Or if you want me to say this, then I will say that what I can say is that a person who has moved from A to B, those 10 kilometers, and then moves from B to C, those 10 kilometers will end up in the same place as a person who has moved from A to C, despite the fact that this is not equal to 30 kilometers. They end up in the same place. That's what I can say. So I can write this as moving from A to B combined with the moving from B to C is the same thing as moving from A to C. Those directions are important to tell us that A to B is a vector in the direction from A to B. And also B to C is a vector from point B to point C. So the arrow there indicates the direction. And of course, AB distance is the one that is giving us the length of the vector. So both the length and the magnitude and the direction, the length and the direction is important. What we have just said is that the quantities that involve both magnitude and direction are the quantities that we call vector quantities. I can write here in brief, because I can't write a lot. Otherwise, we shall spend all time here writing. It's not easy to write. Vector quantities are those quantities that involve both magnitude. They involve both the magnitude and the direction. That is what we have for vector quantities. And we have said that quantities that are not a vector are what we call the scalar quantities. And the scalar quantities involve just the magnitude. So if I define a particular distance in a given direction, then what I'm defining is a vector. But I can define a distance, and it is up to you to be anywhere in whichever direction it is, then that is a scalar quantity. It can be 10 kilometers in any direction, and that is a scalar quantity. Can you hear me? Should I go ahead? Some people can't hear me. Milk. Do the others hear me? Patricia, can you get me?
Yes.
Okay. Then can you write a message to those ones who have not entered with a mic to enter with a mic? I think that they are the ones who have an issue. I have seen already some people who are in without a mic. Please send them a message to enter with a mic. Thank you, Patricia. I can also go ahead and say vectors A and B. I've said scalar quantities, it is mainly the magnitude that is important. It can be in any direction. And I'll go ahead and then mention here that if I give a vector AB and BA, vectors AB and BA, what can you say about them? How related are they? Can I have someone to give us how related are the two vectors AB and BA? Can I have a volunteer to guide us? How related vectors be? Yes, Joshua?
Well, they are equal in magnitude, but they have different directions.
Very good. Can Pesh put it also in her words? Yes, Pesh, I didn't hear. Aisha?
I think vector AB is equal to negative vector BA.
Okay. In Aisha's words, vector AB and vector BA are equal in magnitude. Thank you very much. And they are in opposite directions. It is not just in different directions, but they act in opposite directions. So they are of the same length. If I use those words, are of the same length, but in different, in opposite. They are of the same length, but act in opposite directions, but act in opposite directions. So they act in opposite directions. That is what we know about that. And Aisha goes ahead and mentions that specifically in opposite directions. Aisha is specific to tell us that actually the vector AB, I don't know whether that is what she said, is actually the same as the negative vector BA. So the negative of BA will be the same as AB, or the other way around. BA, so you can put it the other way around, that vector BA is the negative of vector AB. So when I have B and AB, they're in opposite directions, they are equal in length. Then they are, one is the negative of the other. We can also represent vectors using small letters. We can represent vectors using small letters. If I have this vector here, so using small letters, what I'm seeing here is that if I moved here and this is my vector A with a tilde symbol there to show this is a vector. This is my vector B with a tilde symbol there. And this is my vector C. Then I can put it very well that the vector C takes me from a position to another position equivalent to both combined vectors A and B combined. The vector C will move me from a position and take me to another position equivalent to the combined vectors A and B. The directions there on the vector diagram show the directions of motion or the directions of the vectors, whichever vectors we are talking about. So the directions are shown by the arrows on the vector diagram. Oh, Patricia, I'm receiving that. Patricia, let me open that maybe so that you can send everyone. Okay, Patricia, you can now send to everyone. Please send to them how they could hear us. Okay, thank you very much, Patricia. Then we could go ahead and take interest in something else. What are equivectors? If vectors are equal, what does that mean to us? Equal vectors. What are equal vectors? Can someone tell us what they remember about vectors being equal? Is anyone ready? Equal vectors. What are equal vectors? Yes, Queen, Patricia.
Equal vectors have the same magnitude and direction.
Very good. They are vectors of the same magnitude and they act in the same direction. Same magnitude and same direction. We could say equal magnitude and same direction. It's the same thing. Equal magnitude and same direction. That is when we say the vectors are equal. Okay, thank you very much, Patricia, for that. When the vectors are equal, then it is the magnitudes are the same and also the directions are the same. So if I had a vector, they may not have moved from the same position to another. If I have a vector of that nature and I have another, you forgive me, I may not pick the very magnitude, but if I take those magnitudes to be the same, I could even pick another one. I could even pick another. If I have another here, as long as those magnitudes are the same and those directions are parallel, the same, then we can comfortably say the vectors P, Q, and R are equal. Vectors P, Q, and R are equal vectors. So when we are talking about equal vectors, we are talking about vectors of the same magnitude and equal in length. So whenever we have vectors of the same magnitude, equal in length, then those vectors are equal vectors. Since we said for vectors, both the magnitude and direction are important. So we can comfortably say that if they are to be equal, the magnitudes must be considered. And if they are to be equal, the directions also have to be considered. So vectors of equal magnitude and the same length, equal magnitude and acting in the same directions, in the same direction, are equal. Someone to give us some the idea, what the idea they have on parallel vectors. When do we say that the vectors are parallel? Can someone guide us here? What knowledge do you have of parallel vectors? When do we say vectors are parallel? When are vectors parallel? Are you there?
They have.
Sorry for that. Amy?
Vectors are said to be parallel if one is a scalar multiple of the other.
Thank you very much. Joshua? Joshua, do you have what to add to that? Okay, vectors are said to be parallel if one is a scalar multiple of the other. So I can say that vector A is parallel to vector B if I can express A as a scalar, can use K as a scalar product of B. Here I'm looking at K being a what? K being where K is a scalar. So if K is a scalar, and I can express vector A as a scalar product or multiple of vector B, then I can comfortably say A and B are parallel. In other words, one is only longer. I can be, what we have expressed here is that if this is our A, I can, if this is our vector A here, then B could be in the same direction, only that it is shorter. So when I get a number of vector B's, they should be able to add up to give me vector A. So this is what I'm looking at as my vector A. And this is what I'm looking at as my vector B. And a number of B's should be giving me A. Or a number of A's could be giving me B. Either way, then I can say, I can express A as a scalar multiple of B, and so vectors A and B are parallel. If my scalar is negative, then they will be in opposite directions. And we call them unlike parallel vectors. If my scalar is negative, then we are having those vectors in opposite directions, and that's what we call unlike parallel vectors. So when parallel vectors are unlike, then we are talking about the fact that they are parallel. One is expressed as a scalar product of the other, and they are moving in opposite directions. One up, another down. One left, another right, whatever it is. They are parallel, unlike vectors. They are moving, they are parallel, but in opposite directions. So that is what that could be. I have an example here which can give us just to talk about the vectors. What can I have here? Let me try and share an example here. If I share, just to guide us, an example to guide us on vector. Let me try and share the example. Okay. In a parallelogram OABC, in a parallelogram OABC, the point D lies on AB and is such that AD to DB is 1 to 2. Express the following vectors in terms of A and C. You will notice that for us, when we are writing, expressing a vector, we use a tilde or an arrow. In the books that you are using, you may find that they only make it darker, bold. So that is, for us, we cannot make it darker or bold. So we shall use, but they are writing vectors. So do not ask for the symbol. You must show the symbol. For them, they may use something bold or darker for the symbol. Okay. Can you draw that diagram? The parallelogram. Draw the parallelogram. Please. Draw the parallelogram so that we can have the solution here. Draw the parallelogram so that we could have the solution here. Our solution, what are we going to have? We shall have a parallelogram. In a parallelogram OABC, the vector OA is A, the vector OB is B. OC is C. Sorry for that. OC is this thing. Okay. So this is C. And so we are looking at the point D lies on AB and is such that AD to DB is 1 to 2. You may put it wherever you want to put it. I want to put it a little high. This is my D for my reasons. Express the following vectors. Express the following vectors in terms of A and C. Okay, can someone tell me what is vector CB equal to? What is vector CB equal to? Patricia, is your hand up?
Yes, vector CB is going to be A.
Thank you very much.
It's going to be the vector.
Yes, please, I can hear you. Oh. Okay, you forgive me for that. What do I have here? Okay. What we are having is that vector okay, this is a parallelogram. Let me see if I can do better. Right, do better. Okay, let me write in it the way it is. This is O, this is A, this is BC. We already had this. This is the vector A, and this is the vector C. And we were looking at what is the vector CB? That's where we were. And what did we say? No. So what we said was that the vector CB is actually the same as the vector A. I don't know whether that is something comfortable for everyone, but what we are looking at is this vector is parallel to the vector OA, and it is not only parallel to the vector OA, but also equal in magnitude. And we have already said when vectors are parallel, two vectors are parallel and are in the same direction and are acting in the same direction and are equaling, we have already said those are equal vectors. So vector CB is actually equal to vector OA, which is vector A. Can someone get for me vector BC then? What is vector BC? Pesh?
Vector BC is equal to negative A.
Thank you very much. From what we have already seen, BC is equal and parallel, but unlike CB. So it is in the opposite direction of CB. And so we are saying that it is negative A. Thank you, Pesh, for that. Our party C is looking at AB. Is that AB? What about AB? Someone to give us vector AB. Isaac?
Vector AB is C.
Thank you. Why are you saying that it is C, Isaac?
Because vector AB is parallel to vector OC.
AB is parallel, but it's not only parallel, they are even equal. They are even
parallel and equal.
They are parallel, so they are in the same direction and they are equal in the magnitude, in the length. So AB is actually equal to C. Thank you very much.
I have a question.
Can we go to D?
I have a question.
Who is that one with a question?
Katomonji, Perepetra.
Yes, Mr. Kato. Go ahead.
Can I as well say that vector AB is the same as OB minus OA since we know?
It is okay, but that is longer. That is longer.
Okay.
It's going to take you because you are now going to look for OB and then you will then subtract. But the statement is correct.
Okay,
Only
sir.
that it is longer. I expect that if you can already see AB parallel to OC, they are in the same direction, they are equal in magnitude, you should be able to see that they are the same straight away.
Okay.
But the statement OB minus OA is a correct statement.
Okay, thank you.
Our issue is going to be now what is OB, you look for it. And there is where the challenges could come in. Okay?
Okay.
Thank you, Kato.
Okay,
Kato,
sir.
is the Kato a twin?
Yes, Kato is twin.
Kato is a twin. Do you have a brother, a sister?
I have a sister.
Okay. That is good. I am a father of Kato and Waswa. So
Yeah.
you are a son. Okay, can we go ahead? That was a by the way. That was a by the way. Yes, Dina Acham, are you saying something or we continue? Dina?
We go ahead.
Go ahead.
I wanted to answer part D.
Please go ahead and answer. Thank you.
Part D is a third
AD. AD equals to a third. Did you say a third?
C.
Vector
C.
Is very fast there. We agreed that there is a D somewhere. And D divides this in the ratio 1 to 2. For those who may not have followed it, Dina, what Dina is saying is that what Dina here is saying is that the total ratio AB is 1 plus 2. This class total ratio is 1 plus 2. Then that is the 3. So we are looking at AB having 3 parts. Can I request you to mute? May I request you to mute, please? Okay, we can continue. The total ratio is 3. It means that if you divided AB into 3 parts, one part is the AD, then you have the other 2 parts also. So AD makes 1 part of the 3 parts of AB. That is what we are talking about here. AD makes 1 part. AD is 1 part of the 3 parts of AB. And it is from this that Acham, I hope I got the name. Say Dina, I think she was Dina. It is from this that she said it's a third of AB, and I know my AB as C, so it is a third of C. Thank you very much, Dina. And finally, can we also look at NASA? Is it a question or you are moving on to OD? Nasa? Ryan? Ruhangampaire? Can you hear me? You can unmute and say what you want to say. Ryan?
Yes, sir.
Please go ahead, Ryan.
OD.
You are moving on to OD. Go,
yes,
please.
Sir. OD is vector A plus a third of vector C.
OD
is vector A.
Oh, sorry for that.
Plus a third of vector C.
So that is OB. No. We are looking at, sorry. We are looking at OD. So something that we are looking at is, it's where? You show it to me. From here. Oh my God. To there. It is not allowing those straight lines. I don't know where I'm making my mistake. But that is the OD. And Ryan is saying that OD is actually, allow me to bring something in here. So, new slide. Okay, blank one. Okay. Ryan is saying that our OD will be equivalent to moving from O to, is that B? Yeah, to A. That's all. Is it A? O to A. And then it from A to what? To D.
From A to D.
Thank you. Now, what is our O to A? That is the A. And our A to D, I think we got it. We got the A to D. In the third place, in the PowerPoint here, we got A to D by a charm as a third C. And so we can now go and use it and say this is a third C. This is our A to D. Thank you very much, Ryan. This is our E, part E. And finally, can we move our part F? And our part F is looking for DC. DC is from here to C. DC. Hamza, are you there? Hamza, are you there? Innocent, please go ahead. Innocent? Oh, it is not Hamza, Hamiza. Innocent, you have the floor.
Vector DC is the same as DB.
Innocent is telling me that vector DC is the same as
DB plus BC.
DB plus BC.
Which is
someone has a question,
of C.
Innocent, can you give someone a chance to ask? There was someone who wanted to say something. Jonah? Who wanted to say something? Okay, Innocent, continue.
Is 2/3 of C plus A.
Very good. When you look at DB, it is 2 parts. This DB here is 2 parts of the 3 parts of AB. I like that. It is 2 parts of the 3 parts of AB. And of course, BC, which we already know. And finally, what did you say, Sebo?
Plus vector A.
It is 2/3 of?
It is plus negative vector A.
It is 2/3 of C,
2/3
and
of
then
C.
we take away the vector A, because we already have it even in our work. But even if we didn't have it, somewhere we have already said that BC is the negative vector of A. I hope you can see that part. Thank you very much, Innocent. And I think that is our last part. Unless we have Willie, unless we have questions. Willie, you have something that you're saying? Willie, please
I have
go
a
ahead.
question.
Please go ahead.
I have a question. I'd like to ask if it's correct for me to write the answer for part A in a fraction format, like 3 over A plus C, the whole of it over 3.
You are here and you are saying we can use an LCM of 3.
Yeah.
Divide this one is over 1. Then 3 divided by 1, it will give us what?
To C.
A plus C.
Plus C. Very good. There's nothing wrong.
Okay.
We many times we also write it as a third. You pick the 1 over 3 into the vector 3A plus C. That is another way of writing the same thing. That is very okay with you. Very okay. Thank you very much. Okay. That was that part. Maybe just another example before we continue. These examples are just helping us to understand what we have defined up there. Parallel vectors, equal vectors, the word vector itself, equivalent vectors. We didn't talk about equivalent vectors here, but we talked about vectors being combined. So these examples are just helping us to understand that bit. I can give you one other example, I think, and then we continue. Oh, but I think you haven't. That one can work for now. If you feel that you'll need another, I'll give it to you. But you could take a pic of that, and then you go through it. OABC is a trapezium with OA as A, with OC as C, and CB is parallel to, and twice as long as OA. Points D and E are the midpoints of AB and CB, respectively. Find the following vectors in terms of A and C. The first one, part A, is CA. Part B is AB. Part C is ED. Hence, show that CA is parallel to and twice as long as ED. That's something I would have wished that we try out together too. But let me give you a chance first. You first try it out. That's an example. Have you finished taking the shot?
Yes, sir.
Yes.
Okay. Then you can also take this example. These examples I'm using are from Sadler, those who have Sadler. This is Sadler, somewhere page 50, page 50 what? 47, 46. Sadler, page 49. You can check for these examples. Actually, the first one is in 48 and 49 and also 50. So these are examples from our book there. So go ahead and also take that one. Those who may not be having a book, if you have the book, you can go to the book. The unfortunate thing with the book is that it's an example and you may, instead of trying out, you may copy. That will not be good. It's an example in the book, please don't copy. Should I say you have taken? You can make it slightly bigger. Oh, current. Current is this? No. I don't want this. What do I want? Next, I want that one. The diagram shows a parallelogram OABC. You can see it with OA as vector A and OC as vector C. D is the point on AB such that AD to DB is 2 to 1. OD produced meets CB produced at E. DE is H or D, and BE is KCB. Find BE in terms of A and K, find DE in terms of H, A, and C, and find the values of H and K. And find the values of H and K. Are you through?
Yes, we are through.
Okay, you will try out, then we could do. You try out, and then we shall be able to we can discuss later on after your Friday. Okay, then if that is so, then we could continue. Where do we continue to? Please allow me to change my screen. Okay, I want to share this screen here. For courts and members there, we can't get as well. You are giving us feedback. Can you mute? Okay. We stopped at unlike paravectors. We could continue and also discuss more. What more can we discuss? Position vectors and we can discuss position vectors and also
Hello?
Yes, please. Can you hear me?
Yes, I can hear you.
Okay, did you want to say anything?
No, sir.
Okay, then you mute. Position vectors and unity vectors. We could discuss position vectors and unity vectors. Can you see my screen, please?
Yes, I can see it.
Okay, thank you very much, Willie. Was that Willie? I don't know.
Joseph.
Joseph, thank you. Okay. Position vectors and unity vectors. Please go ahead and tell me what the idea you have of position vectors. What is a position vector? Willie, are you answering this question particularly? What is a position vector? Someone ready to try and give us an idea of what a position vector is? Are you there? Can you hear me? Did I mute?
Yes.
You can hear me. Give me the idea of a position vector. Okay, thank you. Now give me the idea of a position vector. What is a position vector?
Hello?
Yes, please.
My idea, I think a position vector is simply any vector at any point on a line.
The vector at any point. Thank you, Jacobs. Go ahead, Jacobs. That is Patricia. Thank you, Patricia. Queen. Yes, Jacob.
Describe the position of a point relative to the origin.
Can you repeat those words? I want to hear them.
A vector that describes position relative to the origin.
Did you say describes? Okay. The position, thank you very much. Those words I think are
yes, sir.
The position vector of a point is the vector which describes, I think he has used it, describes the location of a point from the origin. It will show, or it will explain, or it will define the location of a point from the origin. I hope you have picked that. So if I talk about the position vector of a point P, it will describe the location of the point P relative to the origin, from the origin. So if I was to draw just simply here, please allow me to have a simple diagram here. If I'm to draw, please take these to be my axes, the X and the Y. Now, if I have a point P, if I have a point P somewhere in space, it will not be clear. Now, the position vector, if this is the origin, somewhere there, somewhere there. If that is the origin, the position vector of the point P will be the vector that describes the position of P from the origin. To be the vector that describes the position of P from the origin. So the vector OP is the position vector of P. The vector OP is the position vector of point P. This is the position vector of point P. It is the vector that describes the position or the location of P of that point from the origin. That would be the position vector of P. Okay, thank you very much. Then what if, when I talk about the unity vector, what am I talking about? I talked about unity vector. What is a unity vector? What is a unity vector?
A unit.
Someone is trying. Who is this?
Kato.
Yes, Kato. My
Yes.
son. Go ahead.
I think a unity vector is a unit of one length in a specified direction.
A unity vector is a unit. You have used the word unit again. Can you pick another word?
Yes, I can pick another word, sir.
Let me mute, you unmute, because there are some people who are making. Let me mute, then you unmute and come again. Okay. Kato, please. Kato, are you still there?
Yes, I'm still there, sir.
Please come. What is a unity vector?
A unity vector is a length of 1 in a specified direction.
Okay, thank you very much. Yes, can I hear it in other words? There is a fantasy. Someone is wait, let me first mute you, then you unmute and say it again. Please unmute. There was feedback. Go ahead.
I think a unity vector is a vector with a magnitude equal to 1.
Very good. Those are words I heard from Kato, but with a small verb missing. It's a unity vector is a vector of magnitude 1 unit. Kato put that one properly. It's a vector of magnitude 1 unit. A unity vector is a vector of magnitude 1 unit. Its magnitude is 1 unit. It can be in any direction. Kato said that. Of magnitude 1 unit. It can be in any direction, but the magnitude is 1 unit. Kato talked about length, which is okay. Now, there was a verb missing. I wasn't getting it very clearly, but that is what it is. A unity vector is a vector of magnitude 1 unit. So if you have a vector, it can be in any direction. If it is like this, but you are so sure that this is 1 unit in length, then that is a unity vector. Can be parallel to any other vector. There are some standard unity vectors that we use many times. There are standard unity vectors that we use or that we have made in some standard unity vectors. So we have unity vectors parallel to the OX direction. Have a unity vector parallel to the OX direction. We have a unity vector parallel to the OY direction. And we also have a unity vector parallel to the OZ direction. So in 3 dimensions, we have unity vectors parallel to the axes, OX, OY. And we have unity vectors parallel to the axes. That is the OX, the OY, and the OZ in 3 dimensions, and the OZ directions. So parallel to the X-axis, to the Y-axis, and also to the Z-axis. Can someone give me these vectors, the unity vectors in those directions? Beatrice, are you there? Beatrice, are you there? Yes, Innocent.
OX is the I.
Parallel to OX, we have the I. Parallel to OX, we have the I. That is the I. Some people even put a cap there. Parallel to the OI, what do we call that?
We have J.
We have J. Thank you, Kato. J. Sometimes we put even a cap. And the parallel to the Z-axis. Godfrey Malen. Godfrey Malen, I'm with you. Lena? Lena? Lena, come again. I can't hear you.
We have vector K.
Vector K. Very good. Vector K. Vector K. Sometimes we put even a cap. I'm not used to those caps, but we have vector K parallel to the Z-axis. So I, J, and K are unity vectors. Unity vectors meaning that they are of magnitude 1 unit. So if I wrote here that the magnitude of I, it should be the same as the magnitude of J, and it should be equal to the magnitude of K, and all of this is 1 unit. When the vectors are of magnitude 1 unit, we call them unity vectors. Okay, that is beautiful. We can also get a unity vector that is parallel to another vector. We can get unity vectors parallel to other vectors. Okay, we can get unity vectors parallel to other vectors. Or in directions of other vectors. So if I had a unity vector in the direction of another vector, or how can I get a unity vector in the direction of another vector? I think that is very important. How do I get a unity vector in the direction of another vector? Okay, so find a unity vector. I can use an example here. Find a unity vector parallel to the vector I minus 4j. Find a unity vector that is parallel to the vector 3i minus 4j. So how could we get a unity vector? A vector of magnitude 1 unit, but that is parallel to another vector. Is Willie's hand up? Willie, I don't know whether you just forgot your hand up or it is up. Willie, did you just forget your hand up?
I don't know how to remove it.
I have removed it for you, Willie. Now mute. Let me ask everyone to mute. Let's mute now. Now may I get those who are telling me, how should we get a unity vector parallel to another vector? How can we get a unity vector parallel to another vector? It's quite easy. What do we do? It's quite easy. Yes, Jovian.
Okay, so when they ask us a unit vector parallel to the vector they have given us. And we add the vectors out of the magnitude of what they have given us.
Come again. I hear what you're saying, but I hear the word add there. What is to add?
You add the vector. The vector they have given us.
What if it is 1?
You add 3. Yes.
What if the vector is 1?
You add.
Okay, I think I get the idea. Thank you very much. That's a beautiful guide. We get the vector and divide. Calvin, did you want to say something before I repeat what she has said? Calvin? Someone who did not name themselves, I see you as Techno. Techno, do you want to say something? Precious?
Okay, for me, what I want to say, are you getting me?
Very well.
What I want to say about getting that, okay, they've said to find the unit vector. Me, I think there, the way we are going to get it, we shall get the 3i minus that 4j out of the magnitude of that.
Very good. So if our
that's
vector,
what I have.
Thank you very much. That's beautiful, and it's closely what I heard from, I don't remember the name, but from her, those are close. That's exactly what she said in different words. So if our vector v is the 3i minus 4j, then we shall be pushed to finding the magnitude of v. Maybe that is another thing that we can talk about. How do we get to the magnitude of a vector? Can someone guide us? How do I get the magnitude of any given vector? Anyone to guide us on how we get the magnitude of a given vector? Jovia? Jovia, you got lost. You unmuted and muted again. Yes.
Okay, how we get the magnitude of a vector? We get their squares. For example, like this, I'm going to get the square of 3i. Then I add the square of negative 4j.
Very good. Don't say the I. The j and the I are giving us the directions, but you will get the square of 3 and the square of 4. Add them, and then you get the square root. Thank you very much, Jovia. So this is 9 plus 16. Hope everyone is there. When we add 9 and 15, what do we get?
25.
25, and then get the square root of 25. And what is the square root of 25? That will give us 5 units. 5. So what is the unity vector in this case?
5 units.
Sorry for that. Someone disorganized me.
Excuse me, sir. Excuse me. Sir. Teacher Henry.
What's going on?
Excuse me, Teacher Henry. Teacher Henry.
testimony of a new creation.
Teacher Henry.
Is there.
Hello.
I need a doctor here. Come on, you.
Three.
Where are you?
I'm in the bathroom.
Go to the next bedroom.
Teacher Henry.
Can you get me now?
Yes.
Yes, sir. Okay, let me get back to my network. Yeah, I received a call. I didn't receive it, but someone kept calling. And that's okay. Can I have now my host powers? Someone has taken them so that I share. Thank you. Thank you very much.
Step by step.
Okay. So it's that big. Okay, let me chat go.
Okay.
No, yeah. Oh, yeah.
Okay, I'm going to mute these guys. Please allow me to mute them. Then we could go on. Okay. Sorry for that. Someone disturbed my network, called, and as I cleared, the person insisted on calling. And that is when I went off. But I'm back. Can we move on? I was now requesting for people to put in, to guide us on how we now get the unity vector. How we get the unity vector. Someone was to guide us. Who is ready to guide us on how we get the unity vector?
I'm ready.
Where is your hand up? Serena. Is that Serena?
Kato.
Kato. Yes. Serena is doing what? Serena, you are not saying anything. Okay, Kato, go ahead. Kato, you don't know how to put up your hand. You should put up the hand and request us to.
Okay, next time.
Go ahead.
And now, if you are going to get the finding the unity vector, we shall get the vector divided by its magnitude.
We shall get the vector and divide by its magnitude. Thank you very much. I want you to recall where we were. Where before I got off.
We are finding the magnitude of the
minus
vector.
4j, not so? Then we had obtained the magnitude of the vector as the root of 25, which we obtained as 5 units. Now, what is the unity vector VCAP? The unity vector VCAP, like what Kato is guiding us with, get V and divide it by the magnitude of V. Our V is 3I, the vector, minus 4j, and the magnitude is 5. That gives us VCAP. You can write it in any way that you want. I can write a fifth and put it into 3I minus 4j. Thank you very much. That's the unity vector. You can divide each item. There's nothing wrong with that. You can choose to say it is a 350I, no problem. And also 450J. Either way, whatever you give is okay. This here is okay, even the other one is okay. So you shouldn't tell me that no, Kajimo wants is not really. This is okay. I am comfortable with that. But I'm also comfortable with this other one here. So whichever you give is correct. Whichever unit you decide to give is okay. So that there is okay, the other there is okay. Even the first one before you, whatever, is no problem. You can choose to give this one here. There's no problem with that. So I can choose to give that. That is also very fine. So either way, we are comfortable. Okay, that is the unity vector. So whenever you are given a vector, that is magnitude. When you divide by its magnitude, then you have given a unity vector that is in the direction of that particular vector that you are talking about. Allow me to say some small thing here. Adding and subtracting vectors in that format of I, J, and K. That is the direct. Adding and subtracting vectors. So how do we add and how do we subtract? Adding and subtracting vectors. So when we are given vectors to add, what do we do? When we are given vectors to subtract, what do we do? So if we have vectors to add and vectors to subtract, then we can go ahead and add. For example, suppose I have a very cheap thing here to add and subtract I plus 4j, that's one vector. And if you are to add 4i minus j, what do we do in this case? 2i plus j added to 4i minus j. Yes, Nasa.
We first write the vectors in column form.
Okay, you can write the vectors in column form. May I get someone, Nasa, you will come after. May I get someone who is not going to first convert to column form? Lena.
I think we should add the I vectors independently and the j vectors independently.
So read what I should write.
So we should have 2i plus 4i.
2i plus 4i.
Then plus 4 minus
3 plus a minus j. So 2i and 4i therefore will give us 6i because we are adding vectors in the same direction, and then 4j take away j, it will give us plus 3j. Thank you very much. Nasa come. Nasa said we can convert to first of all to column vectors. So if I have 2i plus 4j, Nasa, are you there?
Yes,
2i
sir.
plus 4j, well, how should I write that?
Is 2.
And I want to add 4i
Same as
minus
2.
j. Yes, it is 2.
2, then 4, down.
Column vector 4, 2, 4.
Yes.
And then
minus, plus.
The column vector.
4, negative 1.
4, negative 1.
Negative 1.
So in the same
then
way,
we add the corresponding ones.
We shall add the corresponding ones. So we shall add the 2 and the 4. And we shall add the 4 and the negative 1. So this will give us 6. 6 what?
3.
6. 3. And I can leave it as a column vector, but it's the same as 6i plus 3j. So I can add them direct collecting like components, I can add them as column vectors. There's nothing wrong. I'm impressed that you can convert the vectors to column, and I can still add them. That is the same way I subtract. That is the same way I multiply by a scalar and combine. So I think we can do all those ones at once. Subtracting, then also multiplying by a scalar, converting. I know, multiplying by a scalar and putting together. Okay, let me give an example. Vector A is the vector 2i minus j, and vector B is the vector 4i minus 2j. So what is 3a minus 2b? Okay, can I get Marlene? Marlene.
You first multiply.
Yes.
You first multiply 3 by 2 and negative I by 3.
3 by 2i minus j.
Yeah.
You subtract 2 by 4i minus 2j. What I've done is just to substitute, because I saw you were skipping that. I've substituted, now go ahead.
Okay, when we multiply 2 by 3, we get 6i.
Very good. So the scalar multiplies by 2i and gives us 6i.
And when we multiply negative j by 3, give us negative 3j.
Very wonderful, negative 3j. Then go ahead.
Minus.
Minus.
First close the bracket.
And close the bracket.
Then minus 2 times 4i, which is 8i.
Which is 8i. Open bracket.
Minus. Now negative 2. We shall not consider it as negative, but we shall have now 2 times negative 2, which is giving us
negative 2, which is negative 4j. Thank you. Please go ahead.
Now, when we're subtracting, we shall change them into column form.
Okay, you want now. Can you subtract from there? Please subtract from there.
We
then
shall
you
have
also write the column form if you want.
6 minus 8.
6 minus 8. All of this is I. Yes.
And then minus 3 minus 4. 3 plus 4 now. It will be 3 plus 4.
When you open that bracket, it becomes a plus.
Yeah.
Minus 3 plus 4, all of this into j. Thank you. Now give me the final. 6 minus 8 is 1.
I'll have negative 2i.
Negative 2i. And plus negative 3 and 4 is?
Plus j.
Plus j. Thank you. You can put them in column form if you are comfortable, if that is what you are comfortable with. But you can also work them out. Thank you, Marlene. You can work them out here without changing to column, and you give there. You multiply by a scalar, and you put them together, and that is it. Okay. I can give an example, but I have already given an example. Do I have to give another? You feel that I can give another example? Okay, I can give this example here. In the book, it is 9, example 9. What is example 9 in the book saying? No. Where is the example? Okay, let's discuss 9. I think we could stop at 9. No. Is the 9? Okay, it's the 9. Let me see if I have example 9. I don't know if I have it. Example 9. The 7. I can give this example in the book, and it is example, it's example 4 actually. Example 4. Okay, let's share this one and we see if it makes tell me if you are getting my new screen.
Yes, I have it.
Yeah, we have it.
Yes, I see it.
Okay, can someone read for me?
For each of the vectors shown.
Yes, Jovia. Dorothy, Jovia, give Dorothy a chance. I have not been seeing Dorothy. Dorothy. Dorothy, you have been given a chance by Jovia. Jovia, thank you. Dorothy, please go ahead. I can't hear. Okay, Dorothy could be having an issue with network. Jovia? Dorothy could be having a network issue. Any person? Okay. Can I have Jovia once again? I'm sorry, Dorothy got lost. Okay, NASA.
The question goes, for each of the vectors shown below, Roman 1 says, express the vector in terms of I and j, where I is a unity vector in the OX direction, and j is a unity vector in the OY direction.
Let us first answer
Roman
that
2.
one. No, let us first deal with that one.
Okay.
Good. Can someone help us to express the vector A, our A vector here? Our A vector in terms of I and J. Lynn, are you there? Lynn, thank you, Lynn. Go ahead. Lynn, you are lost? I've lost Lynn. Are you there? Lynn? Marlene? You are the only man now left standing. Marlene? Kato? Kato, go ahead.
Equals.
It is
3i plus 4j.
Very beautiful. I thought I had you say cos and I was scared. You are taking me to trigonometry. When you look at that, it will be 3i plus 4j. Is 3i plus 4j. Okay, let me have someone else. Marlene, are you now there to give me the B?
We shall have.
Thank you.
Negative 2i.
Negative 2i.
Plus. 3j.
3j. Very good. Now may I have Lena to give me the C? I hope, Lena, you can see the C properly there. What is the C?
For the C, we shall have negative 3i
negative 3i
minus 2j.
Minus 2j. Wonderful. Oh, very good. I thought I loved that because I wanted you to notice those bits here. Very, very good. Thank you very much. What is the second part saying? Come on to read for us the second part. What does it say?
Find the length of each vector.
Find the length of each vector. Good. How do we get the length of the vector now? If I want to get the length of A, what am I going to do? Do I have someone there? Queen, Patricia?
Willie?
Yeah, okay.
Go ahead.
We find the magnitude.
Willie, that's Willie. Okay, Willie, go
yes.
ahead.
I was saying that we find the magnitude.
Yes, how do we find the magnitude? The length of the vector.
For example, for vector A, finding the magnitude, we are going to say the square root of 3 squared
Wait a little, I'm sorry. I wanted to get where to write. What is A giving us? A is giving us the vector 3i plus 4j, true, false?
Yeah.
A is giving us a vector 3i plus 4j. So what is the magnitude of A?
The magnitude of A is the square root.
The square root.
Of 3 squared.
Of 3 squared.
Plus 4 squared.
Plus 4 squared. This gives us 9 plus 16, true, false?
Yeah.
Square root.
Which is 25.
And this is the root of 25.
Giving us 5 units as the answer.
Giving us 5 units as the answer. Thank you very much. 5 units as the answer. Okay, can I have someone else to give me the, where am I?
The magnitude of B.
A of B. That is our B. That is our B. So what is the magnitude of B? I saw some new faces. Let me see if they are still there. New hands up. Dina is not new, but has been quiet. Dina, take us through. Dina's network, I think, let her down the other time. Let me see Margaret. Margaret, are you there?
Yes, I am.
Okay, let me hear from Margaret. Have you gotten the vector B?
Yes.
Our vector B is?
Negative 2i.
Negative 2i. Plus? Is it plus 3j?
Yes.
Please get us the magnitude. What is the magnitude of that one?
The square root. The square root.
Let me first mute, then you come again because there's a lot of feedback. I can't get you. Okay. Margaret, come again. Unmute.
The square root of 2 squared.
I want to hear that negative, Margaret.
Negative 2 squared.
Yes.
Plus 3 squared.
Very good. What does this give to us?
Get the square root of 4.
The square root of 4
plus 9.
And that gives us?
The square root of.
The square root of. And that's enough for our age. we can stop at that. There's no problem. We don't have to evaluate the square root of 13. But if you have the calculator and you feel like, you can go ahead and evaluate. And finally, the third one was what? Now, I think that is enough. The third one, each one can go ahead and work it out on their own. I want us to close this. But before we close, I wanted just to say a small thing on scalar product of vectors. Scalar product of vectors, then we could do close. What do I mean when I say scalar product of vectors? Scalar product of vectors. So the scalar product of vectors, what does it mean? How do we obtain the scalar product of vectors? How do we obtain the scalar product? KTP, please. How do we obtain the scalar product of vectors? KTPJ, are you there?
My network is disturbing.
Your network is disturbing. You put off the video, you will get us better. Put off the video.
Okay.
Okay. Go ahead, KTP. Is it better? KTP, scalar product. What do you understand by scalar product? Okay, the network is not very good.
Kato.
Kato's hand, I can see it. But let me hear from Dina. Dina has failed to say anything since. Dina, can you say something this time? Nowhere. She's still lost. Emmanuel.
Well, thank you so much. I basically think scalar product is multiplying two vectors. Yeah,
scalar product is multiplying two vectors. Which kind of multiplication is that? That is my issue. Which kind of multiplication is this? That's an issue here at hand. Yes, who is there now? Sir, there is a Sir someone. Sir who?
This is Joseph.
Sir Joseph. Hey, Joseph, go ahead.
That multiplication means multiplying the magnitude of the two vectors.
Okay.
Multiplying.
Yes, I hear you. Go ahead.
Means multiplying the magnitude of the two vectors and the angle in between them, not their cosine.
Okay, thank you very much, Joseph. So the scalar product of two vectors A and B, which we write as A dot B, sometimes called a dot product, is the magnitude of a vector A multiplied by the magnitude of vector B multiplied by the cosine of the angle between them, and that is the angle theta. Theta is the angle between vectors A and B. Theta is the angle between the vectors A and B. So That is by definition a scalar product of vectors. We call it a scalar product because it is multiplying scalars. This magnitude of A is a scalar, magnitude of B is a scalar, even the cosine of the angle between them is a scalar. When I have two vectors, one there, another one here, one pointing out and this one pointing out, this theta is the angle between them. Or the other way around, if I have that one there and this one there, both of them pointing in, this theta is the angle between them. Or the other way around, if I have one vector here, another vector here, this one is pointing out and this one is pointing in, then that angle is not the angle between them. You must then prolong to have either both of them pointing in, so that you choose this angle, the angle between them, or to prolong the other one. Whichever you prolong, you get that same angle. So when we are looking at the angle between them, either both of them are pointing out or both of them are pointing to a common point, or that is it. If one is out and another in, then be careful. That's not the angle between the two that we are looking at. Not at all. And I want to wind up, and I want to thank you, but I want to wind up with the properties. Please take a peek of these properties for scalar products of vectors, and then we shall stop there. Take a peek for these properties of the scalar product of vectors, and we could stop there. Where are my properties? My properties are here for these scalar products of vectors. Take a peek. I hope you can see them. I don't know whether they are clear. Is that better? Properties of scalar products of vectors. From the definition of A dot B as magnitude A magnitude B cos theta, it follows that two perpendicular vectors will have a scalar product of 0. The converse is likewise true. If the scalar product of two vectors is 0, then the two vectors are perpendicular. The second property is giving us that A dot A, if you mean the magnitude of A and the magnitude of A and cosine of the angle 0, which means magnitude of A squared, because the cosine of the angle 0, that one there, the cosine of the angle 0 is 1. So you end up with the magnitude of A squared. So vector A is the magnitude of vector A squared. The third property is talking about the commutative property, that A dot B and B dot A are the same. A dot B and B dot A are the same. I hope I'm not writing in the pictures that you are taking. And then they explain to you how it comes about. The first property is talking about the distributive property, the distributive law. A dot B plus C as A dot B plus A dot C. And finally, the fifth property of multiplication. Lambda multiplied by A dot B is the same as lambda A dot lambda B is the same as lambda A dot B. So it is all the same there. So where you multiply the scalar is no big deal. And then you can dot the vectors. That's how those are the properties of dot products. What else do we need here? What we may need here is that you need to master how to dot. How do we dot? How do we obtain the dot products? If I have 3i plus 2j, and I'm dotting this with maybe 2i minus j. What you're going to learn is that when we are dotting, we dot the I vectors with the I vectors. We dot 3i and the 2j and 2i, sorry. We also dot 2j and negative j. Why is it like that? From those properties that we have seen, I dot I is 1. It is also the same as j dot j, and it is also the same as k dot k, and it is 1 from the properties that we have seen. Also, I dot j, from what we have seen, j dot k, and also I dot k. Those ones, when you dot, you get 0. So that's why we don't dot I and j, because it is 0. So you end up dotting I and I. And when you dot I and I, you get 6 I dot I, but I dot I is 1. And here you get negative 2 j dot j, and j dot j is also 1, giving us 4. That's why we are calling it a scalar product, because the result is a scalar. So I want to tell you to go and practice dotting. Then when we meet, we can discuss again the examples of dot products, and that will be what we can need here. KTP, is your hand up? We want to close. Are you giving us a closing prayer?
Closing prayer.
Now why are you laughing at that? Okay, please say what you wanted to say. KTP, what did you want to say?
Well,
Aine?
I'm new here. So
KTP, what did you say?
what time do lessons begin?
Oh, we start at 2. We start at 2. Have you got the timetable? Please go ahead and look for the timetable. You should join the HELP Senior 6 2023 class. Join the group and you will be able to get the timetable and see which subjects you have each other day. And the lessons begin at 2 and end at 4. Yes, Kato?
Yes, want to give a vote of
Oh, thank you very much. I wanted also to thank you for being there, but let me Kato, before you give a vote of thanks, let me mute your vote of thanks. Yes, Kato. Kato, unmute. Go ahead.
Yes, thank you. Thank you, Teacher Henry. It's a great pleasure that you have given us this opportunity to go ahead with studying, not to brainwash as we go back for, as it was in COVID, we shall go when we are super brained. Thank you, Mr. Henry.
You are most welcome. Thank you, all of you, for tuning in. I'm glad that you all connected. And Queen Patricia?
Good evening, sir.
Good evening, Queen.
Thank you so much for the lesson, but I have a concern.
Please go ahead.
I think it would be better if you can mute everyone, because they kept on disturbing throughout the whole lesson. Many kept on unmuting and their sounds kept on affecting the lesson so much.
Okay, I've taken note of that. Thank you for the concern.
Okay, thank you, sir.
Aine? Aine, are you there? Yes, Aine, go ahead. Okay, Aine is failing there, Angela. Let us, next time I will take note of what you want us to cover. but I'm not going to ask for it this time because we must first continue with this work. Okay. So I hope you cling in there. I just chose that this is a simple kind of topic that is all-inclusive. It may not need a lot of knowledge of other topics. It's a wide thing, unfortunately, or fortunately it's wide. We have been still dealing with the basics, but we are going there to see the equation of a plane, the equation of a line, the angles between planes and lines, and so on and so forth. So there's slightly much more than what we have discussed today. So next time we shall just go ahead and add it to this. And if we have a chance, maybe that is sometime after that is when we may change. But next time we shall just add on and go ahead. Dina, you wanted to say something? Dina, I think, and also issues of network. Dina, and then Willie.
I was saying that. Sir.
Yes, please.
Good evening, sir.
Good evening, Dina.
Sir, I was just saying that thank you very much for the lesson.
Thank you, Dina. I think you kept getting disturbed. You're most welcome. Willie?
Yes, I got disturbed because of the network.
Okay, I hope next time it will be better. Willie?
Yes.
Sir, thank you very much for the lesson.
Okay.
And then I have a question.
Please go ahead.
The next time we are coming, are we also going to study mathematics paper 1, or we are going to study paper 2 next week?
Look at the timetable. This particular, I don't know exactly the timetable, but this particular Monday we shall do pure math. However, I'll ask I'll ask Mr. Kaziva, the coordinator, to get for us some slot so that we can discuss paper 2. Okay?
Okay.
I'm going to forward the concern. Eh? You don't have to worry.
Okay.
Okay, thank you everyone. I want us to stop here, but may I request that someone leaves that in prayer. Lynn, say something before we go. Lynn?
Good evening.
Good evening, Lynn. I can't hear you very well. Please shout.
Good evening.
Good evening, Lynn. Go ahead. Go ahead.
I would like, they will send a timetable, so some of us have no timetable.
Okay. I'm going to tell him to resend it. I can also resend it. Okay, I want us to close, but I can see more hands up. Are you giving us a prayer, Jovia? Or you have something else you want to say?
I'm giving a closing prayer.
Okay, give it. Thank you.
Almighty Father, we thank you for the lesson you've had. We pray that you so that King of Glory ever forgive. Lord, we believe that you are person. Then we pray that you bless our teacher for he has sacrificed this to us. We pray and believe in respect to our Lord. Amen.
Amen. Thank you, Jovia, very much. Those who are on, you can open your videos and then say hi. Leonard, you want to say something? Aine, Angela, I can see you, though I can't hear, but I can see Angela. Willie, I can see Willie very well. It's a little dark. Yeah, that is good now.
Excuse me, teacher.
Yes, please go ahead.
I was wondering that I could communicate another slot for paper 2. So, how do we get the communication? Is there any other site where we communicate from? Or
we communicate from our platform. We communicate from the WhatsApp group, our group. Okay? We shall communicate from there. Okay, I wish you a nice evening. All of you, bye-bye. Bye-bye. Bye, everyone.
Bye.
A nice evening.
The name of the WhatsApp group. The number.
Oh, you don't know the WhatsApp group? It is help senior 6 2023. Can I share it here? No, not now. I don't have it nearby. Next time I'll move with it. So that I share and it gets logged on if you're not on. Okay, have a nice evening, please. Bye-bye, bye-bye.
Bye-bye.